Hello, I'm Mr. McBrien. This is TEJ20 Network Cabling. Ontario would like for students to be able to compare the various types of data transmission media for networks, including fiber optic cable, copper cable, and wireless. We're going to contrast some of those today and talk about how to successfully construct copper-based Ethernet cabling. So, we're going to talk briefly about the advantages of wired connections, and then we're going to jump right into how to create an Ethernet cable. So the first thing we should discuss is why bother with wires at all? Wi-Fi connections are so good now. Why even bother? Well, there are many organizations that have a lot of electrical motors running and other machines running inside a given building. And when this happens, it tends to interfere with Wi-Fi signals, and so you can see very slow connections in this context. Even with the best encryption that we have available to us in modern hardware, data over airwaves is inherently insecure, and so we do run risks if we run information across the airwaves. Additionally, we can't always be certain a Wi-Fi connection is going to be good, even if we exclude electrical interference. Why? Unless you have your own Wi-Fi connection, you're competing with your colleagues, you're competing with other people. So when you really need fast access, when it's extremely important, how can you be sure that Game of Thrones isn't going on 5 computers somewhere else in the organization? The answer is you can't be sure. Wired connections are much more robust. So if I've convinced you that wires are important, now we can talk about the different types of network cables. So coax cable isn't generally used inside buildings anymore, other than for TV signals. It has its own advantages, and we'll talk about those later. Typically, it's used outdoors now. UTP, or unshielded twisted pair, is the most typical way to move information inside a given building. Modern transfer of information is done on fiber optic cables, and you can even see some fiber optic cables inside buildings today. Certainly, it's likely the transmission cable of the future. So we're more focused on the transmission cable of today, UTP. So it's unshielded. What does that mean? Well, it means that there's no material there designed to exclude electrical interference, for example, from electrical motors. We alluded to some of that earlier. Pairs of insulated conductors or wires are twisted together, and that twisting is extremely precise, designed to reduce noise from inside the cable, believe it or not, designed to allow for data to be transmitted quickly along the cable without interfering with the other pairs. And the whole thing is covered by an insulating sheath designed to exclude water, stuff like this, and also to provide some strength to these extremely thin wires. There are lots of different categories of these things. We're probably most focused these days not on phone lines anymore, which are pretty rare, but on Cat5e, which we tend to use in our classroom, and faster speeds beyond that. Notice this number representation here, data to 1000 Mbps. What does that mean? 1000 megabits per second, or gigabit Ethernet. You can see the Cat6 cable is about 2.5 times the speed of Cat5e. So Cat5e, gigabit data capacity. It will have reasonable data integrity up to about 100 meters, so we usually try to keep our cable lengths below 90 meters. And stranded cables are ideal for the patch cables we tend to use in our classrooms. Now, you've seen the ends on these Ethernet cables. Those clear plastic ends that we'll talk about a lot over the coming couple of minutes are called RJ45 connectors. Here's one here. You can see the conductive strips that are part of the ends. What you can't see here are tiny little razor blades on the other sides of these. And when we crimp those wires, when we put the end on and install it, those blades pierce the insulation on each of the individual 8 wires and form a conductive join between them. So you might ask yourself, why are we going to the trouble to make cables? Amazon Prime will have us a new cable for $24 and they'll have it to us tomorrow. Why worry about this? Well, in fact, there are several good reasons beyond understanding how a cable works, several good reasons for making your own cables. The first is you get the length you want. So you don't have to pay for extra material and have extra material hidden in the walls. You pay for the length that you need. If you need a 4-meter cable, you make a 4-meter cable. If you need a 17-meter cable, you make a 17-meter cable. You can't buy exactly the length you want very often. And in addition to the cost aspect of that, longer cables are actually a little bit slower than the right length of cable. And it's worth noting, of course, that cables that are shorter than you need are infinitely slower. So, perhaps more important than all those things above, pre-made cables are extremely hard to pull through walls. If you try making holes big enough for those RJ45 connectors, you tend to damage them when you're trying to pull them through walls. It's much easier to pull a simple wire through a wall than it is those RJ45 connectors. Now, additionally, the tabs tend to break off on those connectors. It happens all the time. And you'll see Ethernet cables sitting in e-waste all the time because one of those little plastic tabs has fallen off. If you know how to make a cable, you also know how to repair a cable. So you can take a new RJ45 connector, cut off the old one, put on a new one, and in a few seconds have a working cable. So this saves the cost of buying a new cable, of course. But if you've already pulled a 70-meter cable through a wall, and then somebody breaks off one of the RJ45 ends, you certainly would much rather put a new end on it than pull a new cable. So there are 2 main types of cables we concern ourselves with. That's straight through and crossover. Straight through are the ones you typically see the most of. They connect computers to routers or switches. Both ends are T568A, but they'll also work if both ends are T568B. And what those are is simply the order in which the wires, those 8 wires, are arranged in the connector. A crossover cable will connect 2 computers together without a router or a switch. It'll also connect 2 other similar networking devices. And in these cases, one end is T568A, one is T568B. So if you have 2 computers you want to connect together, and that's all you want to do, you don't need a router. You don't need a switch. All you need is a crossover cable. Now, computers with technology called Auto MDIX, you can use a straight through or a crossover cable for any application you want. It automatically corrects for the, if you want to call it that, user error of using the wrong kind of cable, the wrong situation. Okay, let's talk about how to make a straight through cable. So this PowerPoint is going to go into some detail on how to effectively make a good cable. We're going to use the T568A Ethernet standards. So what are you going to need in order to do this? You need a pair of scissors or good sharp wire cutters. You'll need one of these crimping tools. You'll need a network tester or a cable tester. Now these cable testers only check which pin is connected to which. If you want to check how well your cable is working, you need a multimeter to test the resistance. And probably most of you are aware, in a wire, the lower resistance, the better. Okay, a couple of tips. Be careful for with the sharp cutting edges. Measure twice and cut once, the engineer's rule of thumb. And give yourself an extra few inches past what the requirements are. Look on your documentation to see what length of cable you're going to be creating. Add about an extra 12 inches. So this makes sure that you've got a long enough cable, even if you have to redo an end once or twice. Believe it or not, there's a skill to getting the wire out of that box that you're seeing at the front of the classroom. So when you go to get the wire out of that box, if you do it wrong, you can ruin the wire. So what you want to do, make sure the box is right side up, because when it's right side up, it's designed to easily allow the wire to come out. And you pull it smoothly from the hole that is in the front of the box. If you start to feel resistance, don't yank on it. You'll put a kink in the wire and your cable won't work as effectively. Okay, once you've pulled out the length you need, cut it to the length of the specifications, adding about 12 inches or 30 centimeters. Next, you want to take the ends of your wire and strip off that outer insulation, which is most often blue, but not necessarily in your case. When you do this, strip off about 1 inch or 2.5 centimeters, and be careful not to strip the insulation from the inner wires, those 8 inner wires. So you got to try to be careful about that. Most crimping tools also have one of these stripping tools available. So you can go ahead and expose that 1 inch there. Give it a quick half turn. Don't go crazy on that or you'll wind up cutting the inner insulation. And then you can pull away with your hand, pull away the outer insulation, and expose those 8 wires. Notice that they're color coded. That color coding is critical to the next steps. Okay, so you separate out those wires and you're going to comb them straight. Then you're going to put them in the order according to the 568A standard. You can look that up on the internet. There's a few color cards lying around the classroom, but it's easy enough to look up. So you comb them in that order. That order is critical to the success of your cable. Now once you've got them combed out and very straight, you trim them to just about exactly 1/2 an inch. So you're going to cut them, make sure they're all the same length, using good sharp scissors or wire cutters. You need them the same length so that they're all going to go the same distance into the RJ45 connector. Okay, so here's that process here. You're going to slide them into the RJ45 connector, making sure that they stay in the same order. Now that order is assuming that the tab is on the bottom. So you can see the tab here. If you're looking at the wire colors through that tab, you've got it upside down. So you want to be looking at those wires through the non-tab side, and they should be easy to see because of that. Once you've got them in the right order, you're going to push them all the way in. Make sure that they go all the way through so that the little razor blades on these conductive surfaces are going to contact the wires. If even one of those razor blades misses the wire, your cable won't work. So here's the side view. You should be able to look on each side and see that your conductive material, your wire, goes all the way through to those razor blades that you're going to push into it on the next step. So once you've got that in there, you're going to carefully push it into the crimper, keeping all those wires in place and right to the ends. So you'll need to put inward pressure on the wire to hold it in. Verify that it's in correctly, and you're going to crimp. Use both hands. Don't push it down on the table on the floor. Don't perch yourself on top of it, jumping up and down. You can damage the crimping tool, and if you push them in too deeply, they won't make connection when you put them in the jack. So then you can test the continuity. So this cable tester will make sure that all your wires are connected to the right place. So you can follow that order through, watching to make sure that none of those wires are connected in correctly. Now, if you've got a problem, you have to figure out which ones of the wires are put in the wrong place. If the lights simply don't light up on one side, you may be able to recrimp the wire. If the wrong light lights up, then you're going to have to get a new connector from your instructor, cut away the one that's incorrect, restrip the wires, and start over again. So as far as grading goes, you'll be graded according to how many ends you use, as well as your length being correct, etc. Okay, so key points then about cables. Wired connections have several advantages, especially when users aren't mobile and don't need to be moving around with their computer. Buying pre-made cables is a waste of resources, think money, and makes it much more difficult to pull the wires through walls. Making cables is not a difficult practice once you're used to it. For references, these slides came from the Cisco Networking Academy. I think that's about it for today. Enjoy making the cables, have fun, and have a great night.